Hello again. In this video, we will look at physical quantities. Some define physics as the science of measuring the universe, which includes matter and energy. And the general rule is that if you introduce variables in physics, they should be at least be measurable. That's the general rule. Anyway, what are physical quantities? By physical quantity, I mean a measurement. Um, So describing a specific property of space-time or matter. Time is a physical quantity, so we can measure time with a clock, and the units would be SI units of seconds, or mass is also a physical quantity which we are able to measure. We will look at two types of physical quantities. Here we will look at scalar quantities and vector quantities. As you may already know, a scalar quantity is fully described using magnitude only. Example, a question of what is the temperature in your room, what is the room temperature? The response would be that it is 21 degrees Celsius, and that would be complete. So then temperature is an example of a scalar quantity. Vector quantities, on the other hand, you need both magnitude and direction. Displacement is an example of a vector quantity. If an object moves from point A to point B and you want to describe its displacement relative to point A, so then you would have to measure the distance between point A and point B, and also measure the direction, whether point B is east, north, or south or west. So a response would be the displacement of the object from point A to point B is maybe 50 meters east of point A. So then that's what I mean by a vector quantity. All right. Again, you already know this, but I'm just going to go through them again. By fundamental, we mean that they are not derived. Okay, so these are the base unit, base scalar quantities. They include time, length, mass, temperature, current, amount of substance, luminosity, intensity, and these are their associated units. Right. These scalar quantities, they are derived, and we will do an exercise just to derive some few units using the units that we already know in the future video. But derived scalar quantities, they include work. These are just few examples. Work is a scalar quantity, pressure, power, area, volume, speed, density, and others as well. Okay. And then these quantities are vector quantities. So these are the few examples. Where force is a vector quantity, it has magnitude and direction. Displacement is a vector quantity. Impulse is also a vector quantity. Velocity, electric field, momentum, and acceleration. So these are examples of vector quantities. All right. So now let's look at SI units. SI is for International System of Units. So there's 7 base units. Base unit it's also like fundamental units, and they are just the units of the fundamental quantities. Second, it's a unit of time, and meter is a unit of distance, displacement. Kilogram is of unit of mass. Mole is the unit of the amount of substance. Ampere is unit of current, Kelvin is a unit of temperature, candela is a unit of luminosity intensity. So these are the base units, SI base units. So before we go further, let us just do some exercises to derive some units from definitions. Why not? Right, let's start to look at the process of determining units from definitions. We will start with determining the units of velocity using the definition for velocity, which is rate of change of displacement. So let us write the definition down. The definition states that velocity is equal to rate of change of displacement. So change is delta, and then we will denote displacement as x, and then we rate of the rate part means that we will divide by delta t. So then we have velocity is the rate of change of displacement. So then, okay, the units of velocity should be, well, what are the units for displacement? The units are meters over the units for time, they are seconds. So then these are the units of velocity, very simple, which is normally written as meters with power of -1 there, or meters per second. All right, and then this is also a simpler one. It's pretty much the same as number one. So in here, let's study the definition of acceleration. Acceleration is the rate of change of velocity. We write that down. Acceleration is the rate of change of velocity. Change velocity. Okay, so change is represented by this symbol delta. Okay, so delta is change. All right. Okay, so then the units of A, let's look at the units of velocity. Well, we just determine them as meters per second, so we'll just write that as meters per second here, and then divide by the units of what? Of time, which is second, and then that's basically meters per second to the power -2. Okay, which is shorthand for meters per second, right, in every second. So these are the units of acceleration. Okay, and then let's look at the units for momentum. Again, you use definition of momentum. Definition for momentum is momentum is the product of mass and velocity. So let's first write that down. The symbol for momentum is P. P, which is momentum, is product, so we're just gonna multiply mass and velocity. So thus units of P, which is momentum, should be, what are the units of mass? This is kilograms. And what are the units of velocity? Meters per what? Per second. So these are the units of of what? Of momentum is kilograms meters per second. All right, now you should try also use the same procedure to determine determine the units of, well, force. F, okay, if I'm just gonna give you a definition. If the force is the product of what? Of mass and acceleration. So you can pause the video and then you can work out the units of force using this definition. Alright, so let us use this definition to determine the units of force. So we'll say that force is the product of mass and acceleration. So then, what are the units of force? The units of F are, according to this definition, so if I define the force to be mass times acceleration, then the units will be, in the place of mass, the units of mass is kilograms. Then I times that by the units of what? Of acceleration, which is meters per what? Per square second. Okay, so these are the units of what? Of force. And thus, you can go further and give a definition for this kilograms meters per square second. We state that 1 Newton, which is 1 unit of force, which is a name given to these units, 1 Newton is equal to 1 kilogram meters per what? Per square second. Okay. All right, that's it for now.